Now the fourth question is, when a metallic surface is illuminated with radiation of wavelength lambda, the stopping potential is V. If the same surface is illuminated by radiation of some other wavelength 2 lambda, then the stopping potential is found to be V by 4. Now the threshold wavelength of the metallic surface is one of the 4 options. Now first of all, my dear students, what do you mean by stopping potential? You tell me. Stopping potential means it is a work done to stop the fastest photoelectron. Even the fastest photoelectron has to be stopped, means work has to be done. And the work done is equal to the initial kinetic energy of the photoelectron. That is half mv square maximum. Or it is also equal to E into V naught, where V naught is the stopping potential. So I have already told you in the class that to stop the fastest vehicle, large work has to be done. So initially the stopping potential is found to be what? V volt. Understand? Or V electron volt. For what wavelength? It is lambda. So the energy, the frequency and the wavelength are related. So my dear students, if the incident energy is high, kinetic energy of the photoelectrons will also be high. So stopping potential must also be high. Is it not? So for lambda wavelength, the stopping potential is V. So when it is doubled means by how much will be the stopping potential increases? It is 1/4 of V. Is it not? Stopping potential has decreased because wavelength is doubled, means frequency will be halved. So the stopping potential is now what? 1/4. Anyhow, the same metallic surface only is illuminated with different wavelengths. So the surface, the metallic surface is the same. So the hint given here is the work function of the metal will be the same. That is the hint. Work function will be the same. So we are going to equate that. Two equations of photoelectric equations. Einstein's photoelectric equation I am going to write for 2 cases. So first case, for the first case, the incident energy H nu is equal to work function. Work function is H nu naught. Directly I am writing because other symbol W we can write for work function, or phi naught we can write for work function, or H nu naught also I can write. So plus half mv square maximum. Okay. So this is also now Hc by lambda. Hc by lambda is equal to Hc by lambda naught plus, instead of half mv square maximum I am going to write what? E into V naught, the stopping potential. Now students, this Hc is a common factor. I am going to take it left now. So that this is what? Hc into 1 by lambda minus 1 by lambda naught minus 1 by lambda naught is equal to, instead of E V naught, what value I am going to substitute? What is given in the problem is V. So this is equal to V. So this is equation 1. It is given as V in the problem. Understand? So this is for the first surface. Okay, this is for the first surface. Similar equation for the second surface. For the second surface, what? The wavelength lambda is doubled, is it not? The wavelength lambda is doubled. So for the second time, I can rewrite the same equation Hc into, so this is for the second case. Don't forget, we are not extending the first case still. We are taking the second case. For the second case, the wavelength is 2 lambda. So this is equal to 1 divided by 2 lambda minus 1 divided by lambda naught. Why here lambda naught remains the same? Can you tell me? Because the work function is the same. Why work function is the same? Because the metallic surface is the same. So first factor becomes 1 by 2 lambda because the wavelength is doubled now. The second factor is lambda naught remains the same because the surface is the same. So work function is the same. But when we double the wavelength, what has happened to the stopping potential EV naught? From V to what new value it has gone? V by 4. So here this must be equal to what? V divided by 4. This is equation 2. Have you all understood? Have you all understood on that? Okay, students. So now it is a V by 4. Have you all understood? Shall I proceed? Okay. Now I am going to divide the two equations. I am going to divide the two equations such that the constants, okay, H into C will get cancelled, B and V get cancelled. So dividing, okay, now I will divide. So divide equation 1 by 2, okay, dividing equation 1 by equation 2. So left side HC and HC get cancelled, I need not write now. So this is 1 by lambda minus 1 by lambda naught whole divided by 1 by 2 lambda minus 1 by lambda naught. So right hand side is V divided by, so this is V divided by V by 4. So V also will get cancelled, is it not? On the right hand side, V also get cancelled. So that this will be equal to what? This will be equal to 4 by 1. This will be equal to 4 divided by 1. Now you cross multiply. So that 1 by lambda. So 1 by lambda minus 1 by lambda naught is equal to 4 multiplied by 1 by 2 lambda minus 1 by lambda naught. Now you open up the bracket on the right hand side. So this will become, left hand side is the same, 1 by lambda minus 1 by lambda naught. Okay, this is equal to 4 divided by 2 lambda. So 4 divided by 2 lambda will be equal to what? 2 divided by lambda. 4 into 1 is 4, divided by 2 lambda is what? 2 divided by lambda minus, okay, minus this 4 divided by lambda naught. Okay, students. Now what is asked here is the threshold wavelength, is it not? What is the symbol for threshold wavelength? Is lambda naught. So I am going to group the terms such that one side lambda naught, the other side is lambda. Okay, students. So now I am going to take this minus 4 by lambda to the left side. Minus 4 by lambda is coming to the left side as 4 by lambda minus 1 by lambda naught. So this is 4 divided by lambda naught minus 1 divided by lambda naught. This is equal to 2 by lambda is as it is. So this is 2 divided by lambda. Okay. And this 1 by lambda is taken to the right side. It will become minus 1 by lambda. So that this is equal to minus 1 by lambda. So here 1 divided by lambda naught is a common factor. So 1 by lambda naught is taken as a common factor inside the bracket 4 minus 1. So I will write this is equal to 4 minus 1, and this is 1 by lambda on the right hand side as a common factor. This will become 2 minus 1. 4 minus 1 is 3. So this is 3 divided by lambda naught is equal to 2 minus 1 is 1. So 1 by lambda. So again cross multiply, we get lambda naught is equal to 3 lambda. So lambda naught is equal to how much now? 3 lambda. Look at the 4 options now. 4 lambda, 5 lambda, 5 by 2 lambda and 3 lambda. So which answer is correct we are getting? Option D. Okay, students. So option D is correct. So I will write here the correct answer is option D. See here, this question was asked in the year 2016 in the NEET exam. Are you all feeling it easy now? NEET is not so difficult. You have to write neatly the steps and prepare. Then NEET also will become easy. Okay, we will go to the next sum.